takes care of part 1 here, 1 through 6. All right, we're okay with that stuff?
What is that? That's a direction. That's another direction. I think a couple directional sections.
Let's look at a couple of these. Number 8 here. The ideal gas law says this. Okay. And it's relating pressure, volume, and temperature in a closed system of an ideal gas. All right, so it says, at a certain instant, the pressure is, the volume is, and the temperature is. And then it says the gas is being compressed, so the volume decreases by, and the pressure rises by, and then it wants how much the temperature is changing at that instant. So it gives you all of that information. So now it's going to ask you to solve this problem using, obviously, our calculus techniques to do this, as opposed to any other method you might think of. So what should you write now? What is it asking for? What is this question really asking for?
How the temperature changing.
So what symbolically, what should I write here? What is it that I want?
You want temperature. So you want T equals PV.
That's what it wants,
Yeah.
isn't it? That's what it wants. It wants the rate of change. How is the temperature changing at that instant? That's what it wants. D big T, D little t. Okay, so what should you do?
Solve the D.
You could solve this for big T here. So big T is this equals. Remember, N and R are just what?
Constants.
Constants. Okay. So, what is D big T, D little t? This is a constant, so we can just leave this out. And then what should we write here?
Partial derivative.
Remember how we do this? Because remember, all of these are functions of t. Right? So all of these are functions of t. So if we had generally t as a function of p and v, and p and v are functions of time, then what does the chain rule say? dt is equal to partial f with respect to
P first.
And then just D.
This portion.
D
Yeah.
Oh, DT.
plus
Portion.
Or V.
and then
DP DT.
right. This is the chain rule, isn't it? Okay. All right. So now we have this 1 over nr is just a constant, so we can leave it completely out. So I should write the partial of f with respect to p. What is the partial of this with respect to p?
Just V.
V. And then I would say d.
P over DT.
Okay. And now I want the partial of this with respect to v.
P. DP DT.
And then d.
I'm sorry, DV DT.
V dt. Okay. All right. So that's what the chain rule told me to do. All right. Do I have all this information? Do I have V?
Volume,
Okay, what is that?
30 square cubic meters.
30 cubic meters, so that's 30. Okay, do I have this?
change in pressure. Yeah, one cubic meter per minute. No?
Pressure changing?
Oh, volume, sorry. Oh, 3 kilopascals per minute.
Okay. Do I have P?
20 kilopascal.
And do I have this?
Yes, that's what I said a minute ago.
Yes. So what should you write here?
1 cubic meter per minute.
Careful.
Oh, we gotta change it to -1.
-1. Why?
Because it's decreasing.
Decreasing. Okay, and the only other thing is this business. What is that?
What is it?
Professor, where do you get the V and the P there?
The V and the P.
Where it says DT goes to DT, that line there, how did you get the V and the P?
This is the partial of this with respect to P.
Oh, okay.
Partial of F with respect to V.
Okay.
Got it? So what do I write now?
Both of them are.
Yeah.
Negative. You solve this in the brackets. Let's see.
So,
Do we solve for them, given the original numbers?
yes. How?
Oh, plug them in the original equipment.
Okay, so what would happen?
So if them are 30.
Right on these.
P and V are what?
70.
Divided by, what's the fact?
What's this?
300 Kelvin.
So? 2. That's it. So what's the answer?
You said one by look
And the units, don't forget units. All these problems, units of answers are important. They're worth something. It's part of the answer. So what is the answer and what are the units of this answer? minus 20.
35? Yeah, 35.
Shot for the units cut.
35 what?
Kelvin per minute.
Kelvin per minute. Kelvin per minute. What's a Pascal?
So, pressure.
Pressure for units.
Right, but what is it? How much is it? You know?
I forgot.
That was a guy, yes. Pascal was a guy. He was a French guy. So, you know, it's a Newton per square meter. Pascal is 1 Newton of force per square meter of area. So a kilopascal would be 1,000 newtons per square feet, right? Okay. All right. There's a lot of units of pressure. Another unit of pressure is, of course, millimeters of mercury. So that's kind of a weather unit. Atmospheres is the most common. So normally the pressure on the Earth is what? 1 atmosphere, right? So, which is about 29 something inches of mercury, or 760 millimeters of mercury. So all of these units tie in together. There's also other units. There's bars, millibars, and bars. There's all kinds of units of pressure. But pascals is a very common one. All right, let's look at, let's see, look at number 10 for a second here. Let's see how you would solve a problem like this. Wheat is poured through a chute at the rate of 10 cubic feet per minute and falls in a conical pile. So what should you do right now?
Draw a picture.
I would draw a little picture. Say this is wheat. So wheat is falling through a chute. So imagine there's something here dumping this on here, and it falls in a conical pile. Now it's coming out at 10 cubic feet per minute. Right? And the bottom radius is always half the altitude. What should I write here? Bottom radius. So this radius and this height, if you will, right? So it's telling me that the bottom radius is what? Always half the altitude. Then the question is what? How fast will the circumference of the base be changing when the pile is 8 feet high? Does this problem sound familiar? When did you do this kind of problem?
In calculus 2, right?
Calculus 1, didn't you? This was, what was this called? This was what kind of classification problem? A related? This was a related rate problem. But it wants you to use calculus 3 techniques, of course, to solve this problem, just kind of like we did a little while ago. So what is the question in this problem? The question is what? Symbolically. dc dt, right? dc dt. That's the question. Okay. So what should I do now? Actually, say this is what, when, what? When?
C equals 8? No,
when-
H equals 8.
Yes. So this is the question. What is this when this is true? All right. So how are you going to start this problem? I need to write, what do I know? How am I going to get this involved? Oh, good. What is that?
X squared, Y squared minus Z squared.
Z squared.
Oh, no, that's the equation of a cone.
Yeah.
No, I want the volume of the cone.
Oh,
Because you said V.
so 1/3 pi r squared times height.
Yes, it's a third of a cylinder, isn't